Hey guys, welcome back, I'm Jay. When you build systems on AWS, you should always incorporate architectural best practices into your technical decision. AWS has designed a framework to guide your architectural design with best practices and identify areas for improvement. In this episode, we're going to look at AWS Well-Architected Framework. For years, AWS Solutions Architects have helped design and review thousands of customers' architectures on AWS. They have identified best practices and core strategies for architecting systems in the cloud. AWS Well-Architected Framework is a set of guiding principles to help you design and build reliable, efficient, secure, and cost-effective systems on AWS, aligned with best practices. AWS Well-Architected Framework is based on 5 pillars: their operational excellence, security, reliability, performance efficiency, and cost optimization. The framework provides a way for you to consistently measure your architectures against best practices and identify areas for improvement. Design and build well-architected systems can greatly increase the likelihood of business success. AWS Well-Architected Framework identifies a set of general design principles to help you build on AWS. You should stop guessing your capacity needs. With cloud computing, you don't need to make a capacity decision before the deployment and end up with idle resources or limited capacity. You can use as much or as little capacity as you need, and scale up or down automatically. In the cloud, you can create a production scale test environment and terminate resources anytime. Because you only pay when it's running, you can simulate your production environment for a fraction of the cost of testing on premises. Automation allows you to create and replicate your systems at a low cost and avoid the expense of manual effort. You can track changes to your automation to see the impact, and revert to previous parameters when necessary. You could allow for evolutionary architectures. In a traditional environment, architectural decisions are often one-time events. As your business evolves, your architecture also needs to evolve. In the cloud, you can automate and test on demand, which lowers the risk of impact from design changes. This allows systems to evolve so that the business can innovate as a standard practice. You can drive architectures using data. In the cloud, you can collect data on how your architectural choices affect the behavior of your workloads. It lets you make fact-based decisions to improve your workloads. You can test how your architecture and processes perform by regularly scheduling game days to simulate events in production. A game day is an event to simulate failures and test the systems. This will help you understand where to improve and develop team experience in dealing with failures. AWS Well-Architected Framework has defined 5 pillars of focusing areas. Each pillar prescribes a set of design principles. First, we have the operational excellence pillar. Operational excellence is about the ability to run and monitor systems to deliver business value, and to continually improve processes and procedures. There are 6 design principles for the operational excellence pillar. You should perform operations as code. You can define the entire workload as code for your applications and infrastructure. You can implement operations procedures as code and apply automation. With operations as code, you can limit human error and enable consistent responses to events. You should annotate documentation. In an on-premises environment, documentation is created by hand and used by people. It's difficult to keep in sync with the pace of changes in the systems. In the cloud, you can automate the creation of annotated documentation after every build. Annotated documentation can be used by both people and systems. You can use annotations as input to your operations code. You should make frequent, small, and reversible changes. Design workloads to allow components to be updated regularly. Make changes in small increments that can be reversed if they fail. You should refine operations procedures frequently. As you use operations procedures, you should look for opportunities to improve them. When your workload evolves, improve your procedures appropriately. Set up regular game days to review and validate that all procedures are effective, and that teams are familiar with them. You should plan to anticipate failures, and perform pre-mortem exercises to identify potential sources of failure, so that they can be prevented or mitigated. Test your failure scenarios and validate your understanding of their impact. Validate your response procedures to ensure that they are effective. Make sure teams are familiar with their execution. Set up regular game days to test workloads and team responses to simulated events. You should learn from all operational failures. Improve through lessons learned from all operational events. Share what is learned across teams and through the entire organization. The security pillar is about the ability to protect data and systems, while delivering business value through risk assessments and mitigation strategies. There are 7 design principles for the security pillar. You should implement a strong identity foundation. Implement the principle of least privilege, and enforce separation of duties with appropriate authorization when you access AWS resources. Centralize privilege management and reduce or eliminate the use of long-term credentials. You should enable traceability of your systems, so that you can monitor your systems and alert changes in your environment in real time. Integrate logs and metrics with systems to automatically respond and take actions. You should apply security at all layers. Rather than just focusing on the protection of a single outer layer, you should apply a defense in-depth approach with security controls, including security for your edge network, VPCs, subnets, load balancers, EC2 instances, operating systems, applications and APIs. You should automate security best practices as much as possible. Automating security mechanisms improve your ability to securely scale more rapidly and cost-effectively. You should protect data in transit and at rest. Classify your data into different sensitivity levels, and use mechanisms, such as encryption, tokenization, and access control. You should keep people away from the data. Create mechanisms to reduce or even eliminate the need for direct access or manual processing of data, and reduce the risk of human error when handling sensitive data. You should prepare for security events. Have an incident management process that aligns with your organizational requirements. Run incident response simulations and use automation tools to increase the speed for detection, investigation, and recovery from security incidents. Reliability is about the ability of a system to recover from disruptions, dynamically acquire computing resources to meet demand, and mitigate disruptions and minimize the impact. There are 5 design principles for the reliability pillar. You should test recovery procedures. In an on-premises environment, testing is often to prove the system works in a particular scenario. Testing is not typically used to validate recovery strategies. In the cloud, you can test how your system fails, and you can validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to failures before. This exposes failure pathways that you can test and rectify before a real failure scenario, reducing the risk of components failing that have not been tested before. Your system should be able to automatically recover from failures. Monitor your system's KPIs, trigger automation when a threshold is breached. This allows for automatic notification and tracking of failures, and allows for automated recovery processes to repair the failure. With more sophisticated automation, it's possible to anticipate and remediate failures before they occur. You should scale horizontally to increase aggregate system availability. Replace one large resource with multiple small resources to reduce the impact of a single point of failure. Distribute requests across multiple, smaller resources to ensure that they don't share a common point of failure. You should stop guessing capacity. A common cause of failure in on-premises systems is that you are running out of resources when the demands placed on a system exceed the capacity. For example, the on-premises systems can easily run out of capacity in the event of a DDoS attack. In the cloud, you can monitor demand and system utilization, and automate the addition or removal of resources, to maintain the optimal level to satisfy demand, without over or under provisioning. You should manage changes in automation. Changes to your infrastructure should be done using automation. So you only need to update the automation when you need to change the infrastructure. Less manual update and configuration means less chance of human error. Performance efficiency is about the ability to use computing resources efficiently, and maintain that efficiency as demand changes, and improve as technologies evolve. There are 5 design principles for the performance efficiency pillar. You should democratize advanced technologies. Technologies that are difficult to implement can become easier to consume, by pushing that knowledge and complexity into the cloud vendor's domain. Rather than having your IT team learn how to host and run a new technology, they can simply consume it as a service. For example, quantum computing, blockchain, and machine learning are technologies that require expertise, which is not evenly dispersed across the technical community. In the cloud, these technologies become services that your team can consume while focusing on product development rather than resource provisioning and management. You can go global in minutes. You should leverage the global cloud infrastructure, in which you can easily deploy systems in multiple regions around the world with just a few clicks. This allows you to provide lower latency and a better experience for your customers at a minimal cost. You can leverage serverless architectures. In the cloud, serverless architectures remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services like S3 can host static websites without web servers, and Lambda can host application code without application servers. This not only removes the operational burden of managing servers, but also lowers transactional costs because these managed services operate at cloud scale. You can experiment new ideas more often. With cloud resources and automation, you can quickly carry out comparative testing using different types of EC2 instances, data storage, or system configurations, and find the best fit for your system. You should have mechanical sympathy and understand your systems and technology. Use the technology approach that aligns best with what you are trying to achieve. For example, you should consider data access patterns when selecting databases or storage. Cost optimization is the ability to optimize systems to deliver business value at the lowest cost, potentially zero waste. There are 5 design principles for the cost optimization pillar. You should adopt a consumption model that suits your workflows. Pay only for the computing resources that you require, increase or decrease usage depending on business requirements, not by using elaborate forecasting. For example, if development and test environments are only used for 8 hours a day during weekdays, you should stop these resources when they are not in use. You should be able to measure the overall efficiency. Measure the business output of workloads and costs associated with them. Use this measure to know the gains you make from increasing output and reducing costs. You should stop spending money on data center operations. AWS does the heavy lifting of racking and stacking, and powering servers, so that you can focus on your customers and organization projects rather than on IT infrastructure. You should analyze and attribute expenditure. The cloud makes it easier to accurately identify the usage and costs of systems, which allows transparent attribution of IT costs to individual workload owners. This helps measure return on investment and gives workload owners an opportunity to optimize their resources and reduce costs. You can use managed services to reduce the total cost of ownership. In the cloud, managed services remove the operational burden of maintaining servers. As managed services operate at cloud scale, they can offer a lower cost per transaction or service. In this episode, we've learned AWS Well-Architected Framework. The Well-Architected Framework is a set of guiding principles to help you design and build reliable, secure and efficient, and cost-effective systems on AWS, aligned with best practices based on 5 pillars. They're operational excellence, security, reliability, performance efficiency, and cost optimization. Okay, that's all for AWS Well-Architected Framework. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.